So Mohammed, where's your precious Eddie shortcut or whatever to help you on this problem? The answer is, as Mohammed is furiously typing, the answer is nowhere to be found because it doesn't apply, right? This is not a rational function. The numerator is not a polynomial. So our idea of what is the degree of the numerator is completely meaningless because the numerator doesn't have a degree. It's not a polynomial. However, we are still going to employ our master strategy. We just have to modify it a little bit. Okay. First, I should note one thing. I have this in my notes, probably for a good reason, because I know students make this mistake. Please, for the love of all that is holy, do not write something like the following. I see students write this all the time. They'll say something like, oh, the square root of x minus 9 is x minus 3. They'll do the square root of each term separately. Square roots do not distribute over sums, right? Do not do this. Square roots do not distribute over sums, right? So also, if I have, say, square root of x squared plus 9, that is not the square root of x plus 3. Oh, sorry, x plus 3. Okay, you do not just do the square root of each term. I believe in the very first lecture we actually did go over this with the true or false. Okay, so let's start with our limit. Okay, so because the numerator and denominator, so obviously the denominator is a polynomial. So the idea of asking what is the highest degree of the denominator, that makes sense, that question. But asking what is the highest degree of the numerator, that doesn't make sense because it's not a polynomial. But we are going to somewhat modify that by saying, okay, well, even though the numerator doesn't look like a polynomial, it is the square root of a polynomial. So I'm going to factor out the highest power of the numerator, but keep it within the square root for now. So for instance, what I'm going to do is I'm going to say, okay, inside the square root, the highest power is x squared. So I'm going to factor in x squared from within the square root. So I get x squared times 25 plus 3 over x squared. That whole thing is still under the square root. Now, square roots do not distribute over sums, but they absolutely do distribute over products. So the numerator I can write as the square root of x squared times the square root of 25 plus 3 over x squared. And I can absolutely do that. Again, so far just algebra. Okay, so it looks like I have the highest power of the numerator factored out. Now I'm going to factor out the highest power of the denominator, which is just x in this case, right? The denominator is always the easy part. So up top, I have a square root of x squared, and down below, I'm factoring out an x. So what am I left with? So up top, I'm left with this square root. And down below, I'm left with 9 minus 1 over x. Again, so far, all I've done is algebra. There has been no calculus so far. But now, we've discussed this before. I know we have. You might be thinking, well, why didn't Dr. G just simplify this? Well, I'm asking you, how do I simplify that? And obviously, it's not as easy as you think, or otherwise I wouldn't be asking the question. So how do we simplify square root of x squared? X to the 1/2. It's not x to the 1/2. That would be x to the 1/2 would be square root. Okay, so I got 3 different answers in chat. Let's address them all. So one answer was that the square root of x squared is plus or minus x. That's wrong, right? Remember that the square root symbol, at the very least, is a function, right? If I ask you what is the square root of some number, like 4, the square root of 9, the answer is not plus or minus 2. The square root of 4 is 2. The square root of 9 is 3. The square root symbol always returns one number, right? Because it's a function. So you can't be giving me 2 numbers. You can't give me both plus x and minus x. There's no such thing as that. So that's wrong. The other thing was square root of x squared is also not equal to x. Why is square root of x squared not just equal to x? Can someone very briefly remind us why that's also wrong, even though it looks like it should be correct? Jacqueline, it can take negative values. What do you mean by it? What's the it in this case? The x, right? So think about, what if x is negative? Right? A square root symbol, in case you're, this is sort of the same confusion as the plus minus x. The square root symbol always returns the positive square root, right? So on the left side, I would have a positive number, but if x itself is negative, on the right side, I would have a negative number. No good, right? So the correct answer is already in chat, I think, a few times. So the correct way to deal with this is that square root of x squared is actually equal to absolute value of x. Right? The end result has to be positive. Okay, so continuing with this limit, I get that this is absolute value of x over x times everything else. Oh, Nicole, though. Nicole. What has Nicole said? What do we think about what Nicole said in chat? Swarnima, I think you were saying something, but you're on mute. Do you want to share with us?
Oh,
Maybe?
no, I was trying to see what was in the chat.
Oh, so Nicole said, would we then write negative x because it's negative infinity? And so say, I see a few people in chat. So Jessica Jacqueline saying, yes, true. And yes, true. That is correct. That's going to be the next step here, right? How do I now simplify absolute value of x? Because we know in this class, when you see absolute value, you do not like absolute value. Why? Because absolute value does not play well with algebra, right? You're not allowed to just cancel these things because absolute value does not like to do anything with algebra. It's like a sine x or a cosine x. It likes to stay just in its own little bubble. But the nice thing about absolute value is a lot of times in the context of that limit, we can remove the absolute value bars. And so who was it? It was Jessica, Nicole. Nicole essentially said the next step. So since x is going to negative infinity, obviously we can assume x is negative. So then what? So then that means absolute value of x is actually just equal to negative x. Right? Recall what we do with absolute value. If the inside of the absolute value is already positive, just take off the bars and that's it. If the inside is already negative, you take off the bars and put a factor of -1 to make sure that the end result is still positive, right? Again, x itself is negative. So that's why I need another negative to make the whole thing positive. Okay, now that really helps us because that means now we have algebra. So right here, I'm going to now replace the absolute value of x with negative x. And then finally, I can now cancel out my x's. And notice we have actually not done a single thing of calculus yet. Everything so far has been algebra. The only piece of calculus I guess we really did use was the fact that x is going to negative infinity, but that wasn't really calculus. That was kind of just interpreting what the limit symbol means. So what are we left with? We actually have an overall factor of what, -1. Okay. And now, I think now we're ready to take the limit, right? Now we're ready to actually do the limit. So if I highlight these reciprocals, what do we remember about those reciprocals? They go to 0, right? As x goes to negative infinity, those reciprocals go to 0. So we get a limit of, let's see, the -1 times square root 25 plus 0 over 9 minus 0. So we'll end up with -5 over 9 as our final answer.